Okay, so this is the Chapter 6 test. I'm going to work through one problem from each type in order to just give you a little bit better understanding and help you in your corrections. So if we look at the first one here, where I'm asked to find f of x plus g of x, f of x minus g of x, f of x times g of x, f of x divided by g of x, and f of g of x and g of f of x, 6 things. In order to find the addition of the two, I'm going to go ahead and take f of x, and f of x is simply 4x, and to that I add, we can use parentheses here to help us. I'm going to combine that with g of x, and g of x is 5x minus 1. So when I add, I combine the like terms, so I have 4x's, 5x's, that is 9x's, and then I have a minus 1. I do the same thing when I'm subtracting these two, but I'm going to take this, I'm going to replace it with a subtraction symbol. So now I have 4x minus 5x, and I can break down these parentheses by, so I have a minus 5x, and then a minus negative 1, which is a plus 1. So I have 4x minus 5x, which is going to be a negative x, and 4x plus 1. When I multiply the two, I'll take the same f of x, which is 4x, times g of x, which is 5x minus 1. And then this has to be distributed. 4x times 5x is 20. X and x is x squared. And 4x times negative 1 is minus 4x. Now, division's a little bit different. We're not going to actually go through the act of polynomial long division. I'm just going to set f of x over g of x. And then what I'm wanting to do is figure out the domain restriction. And I know that if I have 0 in the denominator, if 5x minus 1 were to equal 0, that this would error out and I would have a vertical equal to 0. And then I solve. I add 1 to both sides. That's going to leave me with 5x equals 1. And I divide both sides by 1. And so I know that x cannot equal 1/5. Now, f of g of x and g of f of x asks me to actually replace take this and plug it into f of x. So I have 4, and then instead of the x, I'm going to replace it with the quantity 5x minus 1, which is the function g of x, and then we'll distribute that through. 4 and 5x is 20x and minus 4. And we do exactly the opposite when we're going to do g of f of x. So now I'm going to take f of x and drop it right down into the function g of x. So I have 5 times the quantity 4x minus 1. Multiply these two, and then I subtract 1. And that's our last answer there. Let's go down to the next set. Inverse. Remember, when you're finding inverse, you are literally replacing x and y when you just have a relation. So in this case, that would be negative 5, 1. I just flip them. So xy for the inverse of a relation is going to become yx. And then when I'm solving these down here, we'll take a look at 6 first. I write it out, and I get rid of this function notation. Instead of f of x, I'm just going to replace it with y. So all I've done is replace the function notation f of x with y equals. Now, I do the same thing as in a relation, and I'm going to replace x and y. So where I had y, I now put x. Where I had x, I now put y. And now we just rearrange and solve. The first thing I'm going to clear here is multiply both sides by 5 to clear that out of the denominator. And then we'll rewrite. So I have 5x equals 4y plus 1. Now I subtract 1 from both sides, and I divide both by 4. So my solution then, the inverse of this function, Okay. Look at these domain and range graphs. Let's do number 10. Okay, the domain and range here can be found from the basic notation A times the radical of x minus h, then outside of this quantity plus k. This h is your domain. The k is representing your range. This is a horizontal translation and a vertical translation. If you graph this function, I have 3 times the radical, x minus 3, and then outside of that I hit the right arrow over to break the radical symbol. I add 3. And we'll see this is actually slid over 3 units and up 3 units. So I'm going to take this, and from the order I'm going to go 1, 2, 3, and up 1, 2, 3. And so it goes off in that direction. And then my domain, I know, look, the values that I have here don't even start until 3. And my domain, or my x values, head off to the right in the positive direction from 3. So they must be greater than or equal to 3. And I see that number again right there. And it's the opposite sign, because it takes 3 more now in order to equal the same quantity coming out of the radical. And we can do the same thing talking about the range. I see that I don't have any values below 3. So the range is also the set of y values that are greater than or equal to positive 3. And skipping down to the final set here, when I want to solve these radicals, let's take a look at 13. Just like any other equation or inequality, I'm going to make my line differentiating the right side and left side, and now I have to undo. First rule when dealing with radicals or absolute values, I need to isolate this quantity here. So to do that, I get rid of this 15 first, and I do the opposite, so I'm going to subtract it from both sides. So when I do that, I'm now left with the cube root of 5m plus 6 equals 21 less 15 is 6. Now in order to undo this cube root, I'm going to do essentially the opposite, and I'm going to cube it. In order to maintain the balance of the equality, I need to do it to both sides. And 6 cubed, I believe it's 216. So we'll hit our little caret, we raise it to the 3rd power, and it is 216. And then we finish out like any other equation. I subtract 6 from both sides, and I have 5m equals 210. Divide by 5. And I have my solution. M equals 210 over 5, 42. So, work on completing your test corrections. Use these examples to help you work through the other problems that are still in the same set, so they're solved almost the exact same way, and have those ready by Monday. Have a good weekend.